A scientist has 50 grams of a chemical. The scientists need to fill small bottles, each with 1.6 grams of this chemical. We're going to answer these two questions. How many bottles can the scientists fill? And how much mass of the chemical was used and left over? So we have 50 grams of this chemical. I'm going to just write chemical or total chemical. I should just write that. Total chemical. And the scientists need to fill these small bottles with 1.6 grams of this chemical per bottle. So if we need to do that, fill bottles, each having 1.6 grams, and we're given 50 grams of this total chemical, we need to see how many times can 1.6 fit into 50. So this is a division problem. So 50 will be the dividend, and 1.6 will be the divisor. And we need to turn this into a long division. So the divisor goes outside the long division symbol, and the 50 or the dividend goes inside the long division symbol. And we have this decimal here, so we need to get rid of that. And a way to do that is by moving the decimal to the right once, so we have a whole number, which is 16 in this case. And whatever you do outside the long division symbol when moving the decimals to the right, you do the same thing to the dividend. And there is an invisible decimal right after the 50 being a whole number. So we move that to the right one time as well. So we will have this. 500 divided by 16. Next thing, how many times can 16 fit into 5? You cannot. So let me write this a little bit better. Actually, let me just erase all this and then write 16 and 500 there. So how many times can, I should lower this. Sorry about that. 16 and 500. Okay, how many times can 16 go into 5? You can't. So that will be 0 on top of the long division symbol. And then we multiply 0 times 16, and that gives us 0. And then we subtract 5 minus 0, which is 5. And then we bring down the 0, and that gives us 50. Now, how many times can 16 fit into 50? Well, we got to do some multiplication here. So 16 times 2 is, so we have 12, 3, so 2 and 3, so 32. So 16 times 2 is 32. 16 times 3, so you have 18. That's 48. 6 times 3 is 18. 3 times 1 is 3. You add that 1, that's 4, so it's 48. And then 16 times 4, so that'll be 24. And then 4 times 1 is 4, 5 and 6, so it'll be 64. And then I'll just add 16 times 5, so that's 30. 5. 5 times 1 is 5, 6, 7, 8, so that's 80. There. Perfect. So 3 we can use because it's closest to that 50, which is 48, so we'll write 3 here. 3 times 16 is 48. And now we subtract 50 minus 48. That's 2. And then we bring down the 0. Now we have 20. How many times can 16 fit into 20? 1 time. There. And 1 times 16 is 16. And 20 minus 16 is 4. And we can't fit 16 into 4, so we need to add our decimal. Now, this will be our remainder 4. However, we want decimals. So we need to add a decimal here and a decimal here, and that's the rule. And then you add a 0 here, but you don't add a 0 on top of the long division symbol. So we bring down this 0, give it to the 4, now it's 40. How many times can 16 fit into 40? Well, looking at our multiplication here, we could use 2 or 3. 2 will be the best because it's not too far from 40. It's closest to 40. It's closest to 40, so 32. So we'll use 2. 2 times 16, that is 32. And then we subtract that, and we get 8. I'm running out of space. Then we add another 0 and give it to the 8. Now it's 80. We need some space. So we have 40, 32, and that gave us 80. And so how many times can 16 go into 80? 5. 5 times 16 is 80. And you're left off with 0. Perfect. So we can fill, or the scientists can fill, 31 bottles, and there is a leftover 0.25. So 31 bottles are filled with 1.6 grams of this chemical. Now, let me erase all this. Erase all this. Erase all that. There we go. There. I'll leave that though, and I'll erase the 0 here. There. Now, 31 bottles can be filled. Can be filled with 1.6 grams of the chemical. There. Next, how much mass of the chemical was used and what's the leftover? Now that's easy. So we have 50 grams of this chemical, and we have 31 bottles with this 1.6 grams of this chemical. So we have 31 bottles, each with 1.6 grams. And I'll write that a little bit better. There. 1.6. 1.6 grams. There we go. So all we have to do is multiply or add, try to figure out, add all these 1.6 and 31 bottles, and we can just use multiplication for that. So 31 times 1.6 so there's a 0 there. So erase these zeros there. So 0 times 6 is 0. 6 times 1 is 6. 6 times 3 is 18. And then we add another 0 here. And now we're going the other way. 1 times 0 is 1. 1 times 1 is 1. And then 1 times 3 is 3. Oops. And then we add these 0, 7, 9, and 4. And anytime you have numbers after the decimal when you're multiplying, you just move that decimal to the left that many times. So we have one number right next to that decimal and then another number next to that decimal. So we have two numbers next to a decimal. And so starting here, you move to the left twice, 1 and 2. And so your answer is 49.7. Oops, I made a mistake here. Something's not right. 1 times 0 is 0. Sorry about that. So I'll erase this. So the answer is 49.6, not 0.7. We made mistakes. 6. There. So that's how much grams of this chemical was used in the mass. Now, the leftover, all you have to do is subtract this. So I'll erase all this. And 50 minus 49.6. So we want to borrow from this 5, now it becomes 4, this becomes 10, we borrow, and now we have 9, and this becomes 10. 10 minus 6 is 4, 9 minus 9 is 0, and 4 minus 4 is 0. So our leftover is 0.4 grams. So used, and then this is your leftover. And there you go.